We are recording?
Yes.
All right. So, what you want to be looking at is the cami. I should probably present it, shouldn't I?
Yeah.
I will do that. So, I'll present the screen that has the kami on it so you guys can see that, but you can also pull it up. It's posted in the chat window. So, let me do that. Okay, so in the video, hopefully everyone can see my screen. In the video, I do a little bit of explaining how this lesson is review a little bit at the beginning from lesson 20. So we've already done a little bit of work with graphing equations of lines, but we've always done it before by identifying the slope and the y-intercept of a graph. So the goal today is to see how we can create linear equations from a graph when the y-intercept is not clear. And also maybe when we don't even have a graph, we just have 2 points or a point and a slope. So we want to be able to expand our ideas of linear equations to allow us to write any linear equation as long as we have 2 points or a point and a slope. This is some notes from last time. So this is something you definitely want to have in your notes. You should have it already, but it's the slope-intercept form of a line, y equals mx plus b. Remember that m is the slope and b is the y-intercept. It's the place where the graph crosses the y-axis. And then there's also a slope formula, so you would need to have this in your notes as well. And we're actually going to use this in the video. And actually, can someone speak up if you haven't had a chance to see the video? Because I think rather than explaining it a second time, we should just make sure that everyone's seen the video before we start. Unless we think that that would be a waste of time, in which case I guess I could just go through what I explained in the video again. The nice thing about the video was I was able to draw and do some work on paper while I was talking, so it's kind of easier to see what's happening. Was anybody not able to see the video yet?
From the chat, I think most of them haven't seen it yet.
Okay. I guess I could present the video.
Okay.
That might work. I'll do that.
Okay.
Hopefully that's a thing that works nice and isn't gross.
And while he's doing that, guys, yes, good job, Yodaris. Definitely get some sort of paper that you can write on, so you guys can be taking notes. And then after we watch the video together, it'll be a good time for you guys to ask any questions, and we'll go over some problems. So definitely have something to write notes on.
All right, can everybody see this video?
Yeah.
Cool. Hello, everyone. I know many of you have never met me. My name is Mr. Freestone. I normally teach in the high school, but for these few weeks, I'll be working with Miss McCoy and Miss Tetrick to introduce some concepts to you as part of a program I'm in called Indie Teach. I know you have a few teachers like Mr. Weaver who are currently doing the same thing. So today I'm going to go through some review about creating linear equations from a graph. And then we're going to expand those ideas and add to them and introduce a new way to make those equations that doesn't require a y-intercept. Because when you first learned to do this a few weeks ago, we were always doing it by identifying the slope and the y-intercept. So if I had an equation that I wanted to calculate from a line, I would need to be able to find the slope, which is represented by m, and I would need to be able to find the y-intercept, which is represented by b. And to do this, you would normally go to a graph like this one, and maybe the graph looks something like this. and you would identify the slope by drawing triangles. And remember, it doesn't matter where you draw your triangle as long as you go from one point on the line to another point on the line. These are similar triangles, and so any of these will give us our slope. So remember that any slope is the change in y divided by the change in x. So let's take one of these examples, the smaller one. My change in y looks like I've gone up 2. And I can see that from taking the second point, which is from the left to the right. The second point, the y value is 2. The first point, the y value was 0. So I'm going to take 2 minus 0 and divide that by the rightmost x point, which was 0, and subtract that from the leftmost x point, which was negative 1. And sometimes you get these double negatives, and just remember that when you have a double negative, it becomes a plus 1. So this is going to be 2 over 1, which reduces down to 2. And so now I'm going to show you that you get the same answer whether you use this small triangle or this similar larger triangle. The rightmost y value here is 1, 2, 3, 4. So I will put 4 there for my y2. My leftmost y value looks like negative 2. So I'm going to subtract a negative 2. And then I'm going to divide by the rightmost x value, which is positive 1, minus the leftmost x value, which is 1, 2, negative 2. So this time I get 4 minus minus 2, which is 6, divided by 1 minus minus 2, which is 3. And 6 divided by 3 reduces again to 2. So that was a little review of how you are going to go about calculating the slope. The problem is, in this example, I know what b is. Remember, I can find the y-intercept by locating where the graph crosses the y-axis. And I can see from my graph that that value is 2. So if I wanted to write the equation of my graph, I would know that I have y equals m, which I found was 2, times x, plus b, which I also found to be 2. So this would be the equation of my line. The trouble comes when we don't know what y is, the y-intercept is, because it crosses at a strange place. So you can see here that it crosses somewhere between 3 and 4. It doesn't look like it's exactly half, maybe it's a third, but I'm not sure. And so it would be wrong to calculate the slope and then guess what that value is. We want to find a way that lets us find exactly what that value is. And so there are some methods to do that that I'm going to show you now. So in the case where you do not know what the value of the y-intercept is, say for example I have this line, generally you will be able to find some points. So to find the equation of a line, we are going to need some points. So if I show you this example here, take for example this problem from the independent practice. I can identify one point of this line is negative 1, 2, 3, 4, 5, 6, 7. So there's a negative 7, and then up 2. So this is the point negative 7, 2. And it looks like there's another one here that is negative 6 and negative 2. Well, from those 2 points, I can actually calculate a slope. All you need is any 2 points. So if I wanted to calculate the slope, I would use my slope formula. M equals y2 minus y1 over x2 minus x1. And this equation will let me calculate the slope. Just taking a glance at the slope, we should expect something to happen. So on your own right now, before I do any more work, think to yourself, what kind of slope am I expecting? Am I expecting it to be a large number or a small number less than 1? And am I expecting it to be positive or am I expecting it to be a negative slope? So this seems like a good spot to stop and have someone speak up. Anyone have a prediction what kind of slope we're going to have? Anybody there?
Okay, so if you're just looking at the line, is it going to be positive or negative? We'll start there. And you guys can just unmute yourselves and talk, or you can put it on the chat. Okay, someone said negative. And what tells you that it's negative? Okay, 2 people said it's negative. What's telling you that this is going to be a negative slope? It's going down from left to right. Good job.
And the reason I'm doing this guessing thing is because the math of the slope equation is kind of tricky. So like I was showing you before the double negatives happen, there's lots of different things that can happen that will mess up your math. But if you have already from the beginning a good guess, like, okay, I'm expecting it to be negative, I'm expecting it to be a pretty large number, then if you make a mistake in your math, you'll be able to think, oh, wait a second, this looks wrong. I should be getting a negative number, but I'm getting a positive number. Then you know to go back and check your work. That was the only reason I wanted us to practice getting a guess. So with that guess in mind, I'm going to go ahead and plug in the values, and it doesn't actually matter which of these points is considered point 1 and which of these points is considered point 2. I'm going to say that this is point 1 and this is point 2. And that's just important so that I label them correctly. So this would be x1, and this would be y1, and this would be x2, and this would be y2, because you want to keep those straight. You want to keep your 2's and your 1's straight when you're doing this equation. So if I take y2, that was negative 2, and then y1 was 2, and then if I look at x2, that was negative 6, and it looks like x1 was negative 7, so I'm going to subtract a negative 7. And now I do some math. Negative 2 minus 2 is negative 4, and negative 6 plus 7 is 1. And this tells me that the slope is equal to negative 4. Hopefully you predicted that it would be a negative slope and that it would be a value larger than 1, absolute value larger than 1. So this is almost enough. We have the slope, but as you can see, I can't see the y-intercept. It's off the screen. It's somewhere down here. Who knows exactly where it is? We could if we finished writing the equation. So just ignore this one. I'm going to use this space. So I know my slope is negative 4, and I know 2 points. Well, it turns out there is another type of equation that we can use to find the equation of a line. And it comes from the idea of this ratio of changes. So this linear function, we noticed that the slope is something that is a ratio between changes in x and y. And this is true for any values of x and y. So as long as these are points that are on the line, this ratio will remain the same. And that's why this m is so important. The slope is the same between any 2 points on the line. And so an idea that you could have is to say, well, right now I'm choosing 2 specific points. In fact, we had them up here. These were the 2 specific points that we identified at the beginning of the problem. We could have picked any two. Well, what if we know that any point would work? We could just stick to one of them. So let's keep point 1, which is -7 and 2. But we're going to change y2 and x2 to be any x or y, as long as that x or y is on the line. So we want to represent every single possible x and y that could be on the line. And remember, if we want to represent any possible number within a set, then we're going to use a variable. So we want variables, and I think a reasonable choice is x and y. So we're going to replace x2 with just x, and we're going to replace y2 with just y. And I want to be clear about why we are doing this. x2 and y2, y1 and x1, are all representing specific values. That's why they have this little number at the bottom. And when they represent specific values, we can say what they are. We would like to write an equation, and the equation needs to be able to represent all of the possible values of the line. And that is why we're removing the little number and replacing it with a proper variable, x and y, so that it can represent any x and y value on the line. So if I do that, I'll have m is equal to y minus y1 over x minus x1. And this is true for any x and y that I could find on my line. So you could verify that you get the same value of m no matter which point on this line I use. So whatever point on the line I pick is going to give me a true value of m, and I know it's going to be -4. So I'm going to stop the video here really quick. This is the first step in creating the new type of equation of a line that we're going to end up at. And I just wanted to let you guys have a chance to ask any questions if you were confused about how we got here. And then I'll continue the video after you guys have a chance to ask questions. You can type them in the chat, or you can unmute and ask them. And if no one has any questions, just someone say no questions, and then we can move on. But this is definitely something I would like you to follow along with in your notes. So starting here at m equals y minus y1 divided by x minus x1, we're going to do some solving. We're going to solve the equation for y. And we want to do that together. So get your paper out if you don't have it already, and work out what we're going to do here. If no one has any questions, I'm going to hit play again. So I'm actually going to go ahead and replace m also with -4. So, because I know that slope. So now I have -4 is equal to y minus y1 over x minus x1. And hopefully you remember that these are sort of grouped together. I have a numerator and a denominator, and the whole numerator is being divided by the whole denominator. So I'm going to add in those parentheses. They could have always been written there. And now I want to get y on its own side. This is often what we want to do in math. We want to solve for y. I'm not going to completely solve for y, but I'm going to solve for y in that I'm going to get x over to the other side. And so to do that, I'm going to do the inverse operation of division, which is multiplication. So I'm going to multiply both sides by x minus x1. And remember, the reason I'm doing this is so that I can get y on its own, and the reason it's multiplication is because it's the inverse of division. So whatever x is, it doesn't really matter what it is, as long as it isn't exactly x1, it's going to be some number. X is, say it's 10. 10 minus x1 is, a number. And this is a number. Any number divided by itself is 1. So I can remove those from the equation because no matter what number they are, that number divided by itself is going to be 1, and 1 times y minus y1 is just y minus y1. And so we now have Just looking for some space here. I'm going to record all of that here. So I have -4 is equal to y minus y1 over x minus x1. And then I'm multiplying both the top of the right side and the top of the left side by x minus x1. And those are equal to 1. And 1 times y minus y1 is just y minus y1. So now I have m, which was -4, multiplied by x minus x1. And remember that multiplication is commutative. So since these are two terms being multiplied together, it is the same multiplying them this one first and this one second as it is to multiply this one first and this one second. So I'm going to go ahead and rearrange that, and that is just a convention. That just means that many mathematicians like putting numbers on the left side of letters. So I'm going to do that. And then here, y minus y1. And then there's one last piece of convention. Typically, we have y on the left side. So I'm going to rotate this entire equation so that y minus y1 is equal to -4 multiplied by x minus x1. And this type of equation has a name. It is called the point slope form of a line. And it is useful for finding the equation of a line when you do not know the y-intercept. So this is the equation that you want to have in your notes. Y minus y1 equals m, any slope m, multiplied by x minus x1. That's an equation that we're going to use a lot. And it's important that you remember that it's just basically the slope. It's a statement that we know that the ratio between the changes in the y and the changes in the x is always the same amount, and that amount is m. And then we just moved the x's to the other side to make it look more like an equation. And so remember, we know what our point y1 x1 or x1 y1 was. If I go back here and look, it was -7, 2. So if I bring that down and replace y1 with 2 and x1 with -7, this is the tricky part. So if you're using the formula from your notes and you have y minus y1 equals the slope times x minus x1, when you plug in a negative value, when you're plugging in a positive value, there's no problem because it's just y minus 2. I don't think anyone will make that mistake. But there is a possible mistake here, kind of lurking. If I have x minus whatever x1 is, this negative sign is still here, and I'm plugging in a -7. And now, when I simplify this, I'm going to have -4 times x plus 7. And from there, we'll move on to the rest of the lesson. All right, so that's the end of the video. Does anyone have questions about the video or the equation that we are going to use for the rest of the lesson? Cool. So I'll continue presenting the commie page. So hopefully everyone is logged in to that commie page. Now we have the equation that we're going to need. So this is a do now. So hopefully you guys have a place that you can do the do now. Maybe Ms. McPoy can choose a volunteer to do it on the commie page so everyone can see what's happening. But we just want to practice solving the problem the way we learned to in the video.
All right, let's get Ashley. to start us off. So you wanted to do the slope, right?
Yeah, calculate the slope, and then if the class can figure out exactly what the y-intercept is, that's good. But the point of the question is that it's hard to figure out what the y-intercept is. So if we don't get to it, that's fine. The next questions will kind of walk us through how to do that. So what you want to be doing is, anyone want to call out what we need to find the slope? What do we need to get out of the line to find the slope? Right, I see there's one, and then there we go. So we have 2 points. You always need 2 points to find a slope. So very good, Ashley. And then you're going to use those with the, anyone want to remind Ashley what the slope formula is?
Johanna, go ahead and write the formula on the side for Ashley.
So at the top of the graph now, we have the slope-intercept form of a line, y equals mx plus b, which is good, but we want the slope formula. That's the one that is helping you find m.
Good job, Johanna. I'm going to go ahead and draw that line for you. Oh. There we go.
And awesome, it looks like we got the right slope. So in words, the slope is a fraction. It's negative 3/5. And that's exactly right. So now the only question is, how would we figure out what the y-intercept is? What can we do to find the y-intercept? And if anybody has an idea, go ahead and just throw it out. There are no bad ideas. As we keep going through the lesson, we'll learn some ways if you're not sure. But if you have an idea of how we could maybe figure out what the y-intercept is, now is the time to call it out. Anybody have a guess? All right. So, I mean, that was the point of the question, was to show you that it's really difficult to write the equation of a line using y equals mx plus b if you don't know what b is. So that's why we need the new equation type. So here is a space where we want to remember this problem. We want to remember that we found the slope and we couldn't find the y-intercept. And we're going to try and solve it in a second. So the first thing I want you guys to do is we need volunteers to fill in the equations. So two of these you've seen before, slope-intercept form and standard form we covered last time. And then there's a new one, point-slope form, which I just went over in the video. So let's see, who have we got that could go ahead and put some of these on here for us?
Let's have Sierra write the slope-intercept form, Yodaris do standard form, and Charlize do point slope. So all you guys are doing is writing down the equation in that form. So slope-intercept form, when we say that, what does that look like? Okay, so that one's nice. So that's your point-slope form. Let's see.
If you have the page from lesson 20, which was posted a little while ago, I think you should have done work with both of the slope-intercept form and the standard form. So if you don't have it in your notes, now would be a really good time to add it to your notes. But I think that is a place where you could find it if you needed to find it.
And one of these, the slope-intercept form is also on the notes from the handout. So if you want to just scroll up and take a quick look at what that is, if you need that refresher.
Awesome. There's standard form. And this last one is the one that I hope most of you just kind of have in your head as the equation of a line. Yep, that's right. Y equals mx plus b. That is slope-intercept form. So, no need for the question mark. So, these are the three different equations that we can use to write the equation of a line. And so we kind of tried to use slope-intercept form. We tried to use y equals mx plus b on this problem at the top. And it didn't really work because we couldn't find b. We didn't really know what it was. It looks like it's 3 and some change. Not sure exactly how much it is. So let's try using point slope form instead. So if we go back up to this problem, let's try and finish it. Let's try and figure out what the equation of the line is using point slope form. We know the slope now. So what else does point slope form need? If we have the slope already, what else do we need to grab out to finish the problem? Let's see if I can. We're in a text box. So we have y minus y1 equals m, which is negative 3/5 times x minus x1. So what are we missing? What do we need to put in to get the answer still? Anyone want to venture a guess? Make it a good guess. I can't see the chat very well. Did someone say something, Krista?
No.
Okay. All right, so I'm going to leave this here. Like, this is kind of our goal for today, is to figure out how to use this equation. So
think about the name, guys. Think about the name of the form. So it's called point slope form. So you guys already found the slope. What else do you need? So you don't have a b, you don't know the y-intercept yet, right? So that's what we're using the point slope form to try to solve for. Okay, so
we're just looking at the equation. We've got y, which is a variable, and then we've got x, which is a variable. What are these other things? What is y1 and what is x1? What is it referring to? What's it talking about? And remember where that comes from is this equation right here. M equals y2 minus y1 over x2 minus x1. What are y2, y1, x2, and x1 in the slope equation? What are they? Because these are basically the same thing. These two equations. Looks like someone's typing in there. Yeah, it looks like someone has the right idea. And so I want them to finish really quick, and then we can talk about what's going on. Looks like it's Ashley. And she fixed her own mistake, so that's awesome. So that's perfect. So Ashley has figured this stuff out. Really, really awesome job. So this will, if we simplified this, which isn't too hard, we would be able to find out what B would be. But this already is a correct equation. So if you type this into Desmos, it would graph the line exactly like you see it above here. So this is a correct equation for the line. The only question we still have to answer is, what is the y-intercept? And so to do that, what do you guys think we need to do to solve for the y-intercept? How are we going to do that? If I write out, we need this equation right here. Y equals m, which is -3/5 times x plus b. So we want to rewrite our equation to look like this. Y equals 3/5 x plus b. And right now we have a bunch of numbers kind of spread around in different places. So the goal is to figure out how to get all of those numbers into B. And you use algebra, rules of equality, inverse operations, solving equations, that kind of stuff, to rearrange this equation into this equation here. So someone other than Ashley want to start a new text box over here to the right of this work and try and go through the process of rearranging this equation into the point slope, from the point slope form to the slope intercept form. And everybody should be doing this on paper to get practice. The next part of the lesson is going to be a lot of these, rewriting the equation just to get practice. Let's see. Maybe we can call in someone else.
Let's have Charlize.
All right. So Charlize, if you would make a text box over here to the right of these two equations, you're starting from Ashley's equation, y minus 4 equals the slope 3/5 multiplied by x minus -1. And you're going to try and simplify that equation and rearrange it using solving techniques, inverse operations, adding things to both sides, all that kind of stuff, and rearrange it into this form, the slope-intercept form. And we're all going to be doing it alongside you as you do it. So. Is she here?
Yes.
Charlize, are you able to see the Kami document? Are you able to edit it?
Oh, she said she didn't know what she was supposed to do.
Okay. So we're on the first page of the Kami document. Near the bottom of the first page, Ashley has posted her answer to the question, what is the equation of this line? But because we can't tell what the y-intercept is, we have to use a different equation than we're used to. We're using the point slope form instead. And we want to know what is the y-intercept. We're trying to answer this question right here. What is the y-intercept? And we can't tell just by looking at it. It looks a little bit more than 3, but it's not quite 4. It's not quite half between 3 and 4. We're trying to figure out exactly how much it is. And the way to do that is to take this equation that Ashley wrote, y minus 4 equals n times x minus -1, and rearrange it into this form, y equals 3/5 x plus b, so that we can know what b is. What's going to happen is as you rearrange this top equation, you're going to see all the numbers come together through addition and subtraction and multiplication. They're going to combine together into b. So in order to see that happen, we have to do the work to the right here. So if you would make a text box right here and solve Ashley's equation so that you can rearrange it. So, you know, if you want to see what there's a couple steps that I think come out. On this one, there's a difference between the left side of this equation and the left side of this equation. Right, we want to have y on its own. So if we wanted to have y on its own, what would we have had to do to both sides to move this term here?
And that question is for everybody. So someone can just type on the chat, how do we move that 4? Good job. Add 4 to both sides, right? And why are we adding? Because it's the inverse.
Mm-hmm. And we want to make sure we don't go too fast because we've got to, like every time you want to make sure you copy the equation exactly and then make changes to it. So if everyone can see, there's a couple differences between the two equations here. We want to make sure we capture all of the information from the original equation and transfer it over to this new one. And not make too many changes at once. And you guys can help. If you guys have suggestions or this is a team effort, you guys are all on the same side trying to figure this stuff out together. So, you know, if someone's stuck, you can always chime in and help them out. And we can have multiple people doing this at once if you want. Someone else can just hop in and put their work over here. You know, you guys are all in this together. Awesome. So then so her first step, it looks like, was to multiply through the negative 3/5 x. Sorry, the negative 3/5. And that is a very good first step. So negative 3/5 times x is negative 3/5 x. That's exactly right. And then this -1 became +1. So then when she multiplied that, yeah, you did. And then when you multiply +1 times negative 3/5, that becomes negative 3/5. So yeah, this is a correct first step. She distributed the slope. So if you look over here at Ashley's equation, we've got two terms in parentheses. We got the slope, negative 3/5, and we've got another term in parentheses, which is x minus minus 1, which you could also think of as x plus 1. So when you distribute the negative 3/5, that's exactly what you get. You get negative 3/5 x minus 3/5. So that's a perfect first step. So now we just need to deal with the left side. So how are we going to deal with the left side?
And someone already said it in the chat before, but how are we going to move or get that y by itself?
Perfect. Yep, exactly. So now you can use a calculator for this unless you, does everyone remember how to add fractions? So if I've got 4, or if I say negative 3/5, and I've got plus 4, there's a problem with adding these together. You guys remember why this is difficult to add together? I'm trying to add fractions.
What do you need? Yep, denominators.
Okay, so if I need to get the same denominators, this one has a denominator of 5, and this one has a denominator of 1. What could I do to this one to make them have the same denominator?
Let's hear from someone else. Let's see. Sierra, what can we do to make sure those two fractions have the same denominator?
Where's the pencil? Here we go.
Okay. So the question was, you have -3/5 and 4/1.
And this comes from right here. So we're doing a step right here where we're trying to add 4 to both sides of this
So
equation.
how can we add these together? Someone said you needed a common denominator. So how can we find the common denominator for these two fractions? Yep. Okay. So Sierra said that the common denominator should be 5.
Awesome.
So how would we get that second fraction to have a denominator of 5? What do we have to do? And that's a question that anyone else can answer as well. So how would we get that denominator to be 5?
We want this number right here to be a 5 because we want to have these numbers match up.
Good job, Sierra. Multiply by 5.
So we're going to take this bottom part and multiply it by 5. And if I multiply the bottom by 5, what else do I have to do?
You multiply the top or the numerator. Good job, guys.
And the reason why this is allowed is because 5 divided by 5 is 1. And so I'm not really changing my number. This is still going to be equal to 4. If I take 4 times 5, that's 20. And 20 divided by 5 is still 4. So the reason why this is allowed is because I haven't actually changed the number at all. I've just changed what it looks like. So this is now negative 3/5 plus 20 over 5. And so can someone tell me what this new value is? If I take negative 3/5 plus 20 over 5, what's that going to become? Remember how to add fractions. We have a numerator and a denominator. And we've got to figure out how these are going to combine together with addition.
17 over 5. Good job.
Awesome. So yeah, the numerators combine together as normal. And then the bottom number just keeps track of what I'm counting. So in this case, I'm counting fifths. So I had negative 3/5 and I had 20/5. And when I combine those together, I have 17 of those total. I have 17 fifths now. And so, believe it or not, that is the exact amount of the y-intercept. So this number right here is positive 17 fifths because I took negative 3/5 and added 4, and the positive 4 is much larger. See here, the positive 4, the positive 20/5 is much larger than the negative 3/5. So I end up with a positive 17/5. So this number right here, the y-intercept b, is equal to that number, positive 17/5. And so hopefully you can see that that would have been a very difficult number to guess just by looking at this number, this place right here where the line crosses. And so the only way to really know for sure what the amount is to do algebra like this. So that's kind of an introduction to what the rest of the lesson is going to look like. So the rest of this lesson is going through examples, and there's group work and individual work to follow after this. And so I guess I'll leave this here for a moment. If anyone wants to write down in their notes how exactly we did this. Mm-hmm. We need all of this down here. And that leads us to this conclusion.
And we'll also post this video if you guys want to rewatch it again, or the lesson again, and I'll post the annotated Cami as well. Mm-hmm. So you guys can go back and reference it when you're doing your work.
Yeah.
Are there any questions before we go? Because I do know some of you want to join that lunch, and it's past 1. So are there any questions really quickly that you want Mr. Freestone to answer before we end this? No? Okay. So then you guys are free to go. Again, we'll post all of this on Google Classrooms. Mm-hmm. And make sure you're referencing it if you need the extra help. And we'll probably go over it again Tuesday, which is our next live lesson. So if you guys are still a little bit confused, make sure you make an appointment or, yeah. Okay?
Thank you guys so much. Good to meet you all.
Let me see.